Hello, welcome back to Math with Patrick. It's September 21st, and we're solving problem 264 from the Daily Epsilon calendar. And the answer today should be 21 because all the answers to the problems in this calendar match today's date, and it's the 21st. So, if the length and width of a rectangle are increased by 10%, by what percent is the area increased? Cool. So we have some rectangle here. And one way we could figure this out is just by assigning values to the rectangle and just see what happens. So we could do like a 10 over here and a 20 over here. And we could increase both dimensions by 10%. To increase something by 10%, you need to find 10% of that length and then add it on to the original. So for this 10, I would take 10, the value 10, and then add on 10% of 10, which is just 1. And then we would get an 11 right here. And then likewise for the 20, we would get a 10% increase by adding on a 2. And then we would get 22 right there for our larger rectangle. So all we have to do is just compare the areas of these two rectangles and see what percent increase we get. So the area here is just 10 times 20, which is going to be 200. And the area here is 22 times 11, which is going to be 242. And then we just need to see what percentage increase there is between the two. And basically we need to find like 200 times something equals 242. And then once we find this something in like a decimal representation, it's going to be 1.21. This 21 right here represents our 21% increase. Because if we multiply, say, some number here to 1.21, it's kind of like multiplying that number to 1 and also 0.21. And so this 1 right here represents the entire x that I had already. We could maybe like distribute the x to kind of prove my point. Where this part right here is just x. It's the thing that we already had. And so when we add on this bit right here, that's our percentage increase. And so when we find the decimal representation of our number right here, it's going to look like this. And we're going to get a 21 right there. And that's going to be our answer for today. So to figure out what this kind of mystery number is, I'm going to do, S for scale factor. We can just divide both sides by 200. And then here, I think I'll just divide the top and bottom by 2. I'm reducing my fraction to 121 over 100. And then I know that when you divide by 100, you can just move the decimal place over twice. And so that is how I know that the scale factor is 1.21. And this 21 right here is our 21% increase. Cool. We didn't really need to assign certain values to our rectangle. Like the 10 and the 20 aren't special. They're just numbers that I felt like were like easy to use. We could have had a rectangle with an area A by B, and then we would have a new rectangle whose dimensions are 1.1A and 1.1B, because this number right here encodes a 10% increase. And so the area of the original rectangle is just A times B, and then the area of the new rectangle is, multiplying the two dimensions together. And then here, knowing that multiplication is commutative, we can do it in any order that we want. I'll just multiply the 1.1s together. That's like kind of like 11 squared, just moving the decimal place where it's supposed to go. And then I also get times A times B in the end. This right here is just the original area of the first rectangle. And so I'm getting that the new area is 1.21 times the original area. And this expression is what we had essentially right here. That shows me that we do have a 21% increase here. And it doesn't matter what the dimensions of the original rectangle are. I guess, they would at least need to be like greater than 0. Like they need to be positive for this to still have a 21% increase. But besides weird niche cases of like trying to invalidate my claim or whatever, we're going to get a 21% increase no matter the dimensions of our rectangles. So I wanted to do it with like actual numbers, and then I also wanted to do it in an algebraic way. And either way, we can get 21%, and we're all done. So thanks for watching, and I'll see you tomorrow.